Okay, can everyone hear me? I can hear myself, so that's a good start. So as the speaker before lunch, I'm supposed to make a joke about how if I go long, everyone will be unhappy, so don't worry, I'll go short. So I'll tell you how we built our system to scale to 1 million queries per second. So this may not really seem like a big number, but actually when you compare it to companies like Google or Twitter, it's actually several orders of magnitude more than the data they have to deal with every second. That's because people are typing their queries. Our queries come from people loading websites in which ads are shown, and we have to decide what's going to go in those ad slots before the page loads. So we don't have very long to do it, and there's a lot of people loading pages all over the world. So just a quick background about DataXu. We're a Boston company founded by rocket scientists from MIT. One of them is my boss. I'm not a rocket scientist, unfortunately. And we have a platform that helps our customers optimize media placements. So in the old days, people bought ads on TV or radio or magazines, and they tried to guess who was going to watch those ads. But now it's a lot more precise in that you can precisely say, okay, on this website, I'm going to show this ad to this person at this time. So that actually helps people really spend their money wisely and invest in media wisely. So we have a lot of data, and our aim is to leverage that data to engage our customers and to engage their customers so that everybody wins. So this is a scale conference, and thanks, by the way, for inviting me. I wanted to give a scale of what we have. 30 petabytes of data, 1 million requests per second. Actually, that went up recently to 1.2 million, and if you're very sharp, you will notice on one of the latest slides that it actually says 1.2 million, I noticed recently. And we are running 24/7 in 5 continents, which I thought was very cool, being Australian, but then I started getting email at midnight from people, so I actually don't think it's as cool as I first thought it was. But really, it is cool that we are now, like, the sun never sets on DataXu. So just a bit of background about how this advertising revolution works, because I think a lot of people in this audience might not really be in this field. And in fact, I knew nothing about it before I joined the company. So advertisers work with companies like DataXu, which are called Demand-Side Platform, or DSP. And we can provide, for each person that may see that ad, sort of targeting to that person. We don't know who you are, but we are targeting parameters about you and parameters about where we're showing the ad to, so that hopefully those things match and you're seeing an ad that you're interested in. In fact, the whole aim of our company really is, in some ways, to make the internet free or cheap, because the advertising actually pays for a lot of the internet. So if we can make it more efficient, it's good for everybody. So it's not just online ads, it's mobile, social. We actually partner with Facebook, and some of the ads you see on Facebook would be placed by us. And TV is coming very, very soon. So what we work with is something called real-time bidding, or RTB. So the idea of this is that users will go to a page or a mobile device, a place where an ad could be placed. And this generates, behind the scenes, before the page is even loaded, a request to an ad server or an ad exchange. So people like DataXu connect to that ad exchange. So the ad exchange says, okay, I've got this web page, I've got these people, here's the parameters, what are you bidding? So our job is, within 10 milliseconds, to respond to that bid with what we think that ad is worth on that page. We choose amongst the ads we have available for all our customers. We have hundreds of customers, so that's already a challenge for us to decide which ad is going to go on each opportunity. And anyway, we reply with a bid, and if we win, we get to place the ad, and then we write that down. That's one of the statistics we have. And then we also take a note of the user's cookie, or sometimes we use other data to track the user. But in any case, we can tell later if that user then, when they saw the car ad or they saw the cell phone ad, did they then go and look at the cars on the website of the advertiser? Did they build a car? Did they sign up for a test drive? All these things are information that we can use later to calculate the statistics of, okay, next time we see somebody who looks like that, what are we going to bid for that ad? Is it worth it to us, or will it not work? Same thing with the cell phone. Are they going to buy the cell phone? Great. Then we're going to look for more people like that who are interested. If you're not interested, we'll show you a different ad, hopefully something you are interested in. So this slide kind of gives a flavor of some of the data that helps us decide. Some users, we have a lot of information because it depends how often you clear your cookies and where you live and things like that. But sometimes we definitely probably know your age and gender. We might know if you're in market for buying a flight or what your job is. We might just know the field of the job. We don't always know this information about everyone, but if we do know it, it's very helpful. Otherwise, we definitely probably know what browser you're using, and even that can give us information. If it's a mobile device, we know what the device is. Different people who buy different devices kind of have different personalities, and so that's information. You may not think it's worth it, but really, when you have a lot of statistics and a lot of data, it all kind of adds up, and you can beat the averages by going for those devices that personality suits that ad. We also would know the time of day we're serving the ad, and from your IP address, we can determine where you live in the US. We can work out actually what time of day it is for you if you're in a different time zone. So all this information comes together. So on the right-hand side of this slide, it's sort of showing the stream of web pages coming in and where we might place an ad. We might actually reject most of those web pages for that user because it's not really going to work, it's not worth bidding, or we bid very, very low. But on number 3 there, we actually placed an ad because we thought it was worthwhile. So this is another slide, really just I put here because this conference is all about scale. I wanted to show that there are a lot of big numbers here that we have to worry about. Because it's not just dealing with those requests, we have to make a lot of decisions whether or not we're going to place the ad on that page for that user. I'm not a real expert in most of the system, even though I've been with the company a long time. There's like the code ninjas who write a lot of the stuff that makes all the real-time system work really well and the databases work really well. I'm an expert in the predictive modeling, and that's what my team works on and I've worked on for a long time now. So I'm going to spend much more time now going into how that works and the secret sauce, I guess, without giving away too many secrets before we go public. So here I'm showing the flow of data through our system. Is there a pointer? No? All right. So on the right-hand side, I hope, yes, the same for you, we have data coming in from what's called partners. And this is the people who are telling us, OK, that's a female. That's a person in market for flight. That is coming in. We don't have that for everybody, but when we have it, it's useful. Sometimes advertisers are still old-fashioned, and they still want to target, OK, I'm selling cars. Please give me people who are in market for cars. But sometimes they're more open, and they want to do a more general advertising across the internet. We also have what's called media traffic. And this is when we work with companies, we put what's called pixels on their websites. So then we can track, OK, that person came in, and they went to this car. They built this car. Or they went and they booked this flight. We know that that's happened, and we know whether or not we served an ad beforehand. So we know that person is generally interested. Oh, thank you so much. Awesome. How does it work? Can you see it? Oh, it's very tiny. OK, fine. Right, where was I? So that comes in too, and we write it all down. Also, when we serve ads in the real-time system, we write that down as well. So that comes in through logs. So all of this comes in. It's filtered, decorated, et cetera. And then we have to do what's called attribution modeling. So in advertising, you get credit according to what's called the attribution model. So the classic model right now is called last in, which everyone agrees is not perfect, but at least it's simple. So that means if you serve the last ad before the person converted, which is typically buying a product or doing some activity that the advertiser cares about, then you get credit and you get attributed. So for machine learning people like me, that means, OK, great. That's a label that says, yes, that's a positive example of some people we want to try ads on in the future. Otherwise, why did that happen? Don't know. Coming back. OK, great. Otherwise, you're a negative example. So that information goes into the machine learning part of the system. It's also stored, obviously, for our own records, also stored for our own research. Some of it goes into the user interface, because the great thing about advertising now is advertisers have much, much more information about how they're investing their money and then how that then works or doesn't work. So they're very, very interested in this, and that part of our business is only going to grow. And we're going to need much more. Users are becoming cleverer. In fact, they want to do their own queries rather than just get the canned reports that we can give them. So we're just working on that as much as we can. Meanwhile, we're going to use the data to improve the bidding and improve the performance of the advertising. So the machine learning feeds into the real-time system. So this is don't worry about this slide too much, it's just showing the real-time system. What's really important is obviously it scales heavily because it has to run now in 4 geographies, it's hundreds of machines are multi-threaded, because we're dealing with these million requests per second. So the part that concerns me, because I'm doing the machine learning, is that I need to, every hour, send the latest models to what's called ad matches. And these ad matches, again, multi-threaded machines, et cetera, they have certain restrictions, and that's going to restrict the sort of modeling that we do. Otherwise, the whole thing won't work. So what are the requirements of bidding? For starters, we have to return a bid in 10 milliseconds or less amongst all the advertisers we care about. If we don't do that, the web page won't load in time. It just won't work. We have to adhere to the memory requirements that are set by the real-time system. They can only have so many threads running, or we have to buy new machines. So whatever they say is the limit, we have to stick to it. Same thing from the advertisers. They've said, we're going to invest so much money per month in this product. You have to spend that money. You can't spend it all at midnight on the first day. You can't spend it at midnight on the last day. You have to spend it regularly throughout the campaign. They can set some limits, but generally we have to make sure we spend the money properly. So pacing is important. Next, we have to make sure that the models are accurate. It wouldn't be profitable if they weren't. So we have to update them regularly. We typically train once a day. So whatever we do, we can't have a neural network or something that's going to take weeks to train. That wouldn't work. And we like to have custom models for every advertiser because every business is different. It makes a lot of sense. Whatever we do, we have to be able to scale it to multiple advertisers. The more advertisers we have, the more models we have. Finally, I've said we have multiple algorithms per advertiser. Within the user interface, you can actually change those algorithms, and you can have your own algorithm. If you're smart enough, you're a big company, you have analytics team, you can bring those people to the table. They can write their own algorithm, they can bring in their own data, and they can do their own thing. In addition to our sort of canned algorithms that are tuned to your advertiser, but they're more standard. So another quick slide with a lot of data on it, because I think I'm running out of time. This is just showing all the features we have, and they're sort of divided into 3 categories. We have the context of the website, and there's many features of that. It could be a video, it could be mobile. There's the site, there's the ad exchange. In fact, different ad exchanges have different flavors of websites that they sign up contracts with. We can figure out the categories of that site. So all these things go into our classifier. We have data about the consumer, which I showed earlier. Like we might know a lot about them. We might know almost nothing. We might just know the browser they're on. But all this information comes in. And finally, the actual ad is what we're showing. Well, it makes a lot of sense to use that to also optimize, right? So if there's certain ads that appeal to people in different parts of the country, you would soon learn that from a machine learning system. So we do that as well. So how do we actually do the machine learning? Well, we use what's called naive Bayes, a Bayesian method. And this is a compromise. It's not the best machine learning method ever, but it's very fast to train. It's easy to debug. It's very well suited to parallelization. So we use a Hadoop cluster running in the cloud to do that, which is awesome. And our business is very seasonal, in fact, because we typically have tons of customers in the last quarter of the year, which is when everyone spends their money on advertising. So, in the other parts of the year, we can shut it down, have less nodes, save money. And naive Bayes actually has pretty competitive accuracy. Okay, it's not the best classifier, but for now, it's not bad, and it certainly satisfies all the other requirements. Now, we don't use all those features I showed on that last slide in every classifier. We consider them, but then we just eliminate the ones that don't provide information. So some advertisers, the size of the creative may not be very important, but some advertisers, it is, so we put it in. So beforehand, we do feature selection to eliminate bad features, or less informative features, not bad. And this saves a lot of memory and performance. Finally, the actual bid level is set by the users, which is very important. It turns out users actually want control over what they're doing. They don't just want an automatic system, which was our original vision. So letting them have that little piece of control is actually great. So the bid value is sort of multiples of that sort of base value that the users set, and that's based on the probability of conversion, which we learned from the classifier. So that's all well for bidding, but what about pace? So remember I said you couldn't spend all the money at midnight. You need to spend it sort of regularly throughout the ad campaign. So our solution to this is actually to separate the two problems. So we have bidding as one problem. One team works on it. Pace, historically, in our company, is actually being worked on by another team, although my team's now taking over it. Now it's a bit bigger. So the pace tries to keep it on pace. So what happens is the bidder, we give a preliminary bid, and then that's adjusted by the pacer. So any campaign that is on pace will just get throttled for a little while. And you've got plenty of requests coming in and plenty of advertisers to keep bidding on. So those ones will bubble up to the top and bid for a while. And then when they get on pace, they'll bubble down and new ones will pop up. So that's how we deal with the keeping on pace issue. What about flexibility? So as I said, our original vision was to automate everything. But it turns out users do actually want control. We've discovered that almost immediately when we found that users wanted to separate the advertising budgets into different geographies. And we thought they would just do the whole US in one campaign, but no, they want to break it up because they have certain budgets and certain reasons for doing that. It makes sense. They're the user, so we listen to them. So in addition to being able to set the bid value, the users are able to choose from a variety of algorithms in our product. And these are just minor tweaks to the algorithm. But we used to set them on the back end, but then we actually exported them to a higher level so that any user could use them. And so some algorithms work better in certain situations, so we're able to advise on that. In fact, Facebook has their own algorithm because they're different to other websites, so you can imagine there's some slight differences. So you can always add new features to the models using configs on the back end. So when we originally designed the system, there was almost no mobile advertising whatsoever. It's of course grown a lot in the last few years. So we just added that as new features. And also, as I mentioned, you can have custom algorithms. So if you have your own data, you can bring it into the system. If you have your own idea for an algorithm, you can try it out. And the reason you can do this in our system, we designed it from the beginning that we send the code and the parameters every hour. So if you can write code that will run in our bidder, you can test it and make sure it works. But as long as it works fine, then we're happy to have it in there. So this is a really good icebreaker, in fact, with larger customers who definitely have already analytics teams and their own ideas. They've been working with this product for a long time, and they know what works. So they want to bring in their own things. And that's fine. We love that. So the curse of flexibility, though, is that it actually gets really hard to manage a really complex ad campaign for a large customer because it turns out they have hundreds of bids and budgets that they would actually like to change every day. The original thought of the system, of course, would only have like 4 or 5 of these per campaign, but that's not how it really works in the real world. So we actually introduced a new feature this year that helps them manage that. So this is another algorithm that's in our system that uses something called constrained programming. It's actually back to rocket science math, which is pretty cool. And this is a lot more efficient than a human operator. So it automatically you can seek the best level of bids and budgets when you run it. I have a picture of it. So the idea is that into this campaign, which is for Ford, one of our largest customers, they can get an improvement in cost per action, which is one of the metrics they tend to use, if they make the changes suggested by this. And this, if this works, yes, this is showing that how the bids and budgets will change, and this is projected improvements, and this is the overall improvement that they'll see. So typically, customers would want to have the lowest price and spend all their budget. It's actually bad not to spend an advertiser's budget because then they'll have to go back to the manager and say, oh, I didn't spend that, and hand the money back. They would prefer to spend it all, and they would obviously prefer to get good performance for that too. So this tool can help them do that. Running out of time, but these are the lessons I think we've learned over the last 5.5 years at DataXu. It's good to divide and conquer. It's good to keep things simple to start with, but then listen to your users and then move in that direction. Otherwise, you'll have a product that no one will buy. And it was great that we built scale in from the start because it's very, very hard to add later. And what's coming is we are, in our haste to get to the minimum viable product, we didn't really include enough APIs. And that's really, when you have lots and lots of users, then you'll find they will have different ideas of the workflows. And it's really hard to make every single workflow. So if you just have an API, they can write their own workflow. It's great. We want to have more flexibility because we realize the more this market is growing enormously, and the customers are very, very diverse, and they're all from different countries as well. So the more flexibility we can have, the better. Mobile and video are huge now. They were very, very small when we started. Now they're huge. And we've got a lot of complexity in our system, so recommenders is how we're going to manage that. So my team will be working a lot more on recommenders in the future. So I have 0 time for questions, but maybe that's false just to move me along, or it's real. One question. Yep.
So Beth, you told us about some of your current scaling challenges. What's your big fear for the future? Is it like scaling like the kind of classic, you see your latency window, diminishing, or is it more this kind of complexity of use and algorithm?
It's the latter for us. I mean, in general, the company's biggest problem has always been scale. It's just the industry has grown so quickly, and we've been to keep up, but it's always it's a good problem to have. And in my team, our machine learning has held up pretty well, but just the managing of the campaigns, we actually spend a lot of time helping campaign managers pick the right algorithms and fix things that aren't working. And we realize that for newer people, it's just really hard to manage it. Often, for some reason, they get put on these big campaigns because there's usually multiple people doing it. And then they're sort of struggling because it's really hard for them. So if we can recommend things to them, that's the easiest. Thanks.